Here we go. Guys, I'm recording and you're kind of loud, so settle down. Um, oh, you want me to share it to your screen? Yeah, I could do that. So on this first example, it says solve the system of linear equations by substitution. So prior, in our last example, we graphed the two equations, and then wherever the two equations intersected, that was the solution. And basically what we're looking for are two well, an x and a y value that makes both the equations true, and that occurs at the intercept. Okay, so let's get started. All right, so prior to this, we would just graph these two equations and just solve them. But one thing that we can do is we could do what we call substitution. So when you do substitution, remember to graph it, we had to make it look like y equals mx plus b, right? So that's what we need to do here. So how do I make this equal y equals mx plus b? Well, I'm just going to add 3x to both sides. So if I add 3x to both sides, I get y equals 3x plus 1. So that's just this equation, equation 1. And with a little bit of algebra, I made that first equation equal y. Now, you don't always have to solve for y. Sometimes you could solve for x. Now, what's cool about this is I could take the second equation, and wherever there is a y value, I can plug this in for y. That's why it's called substituting. So if you look at equation 2 is 4x, right? 4x plus y. So this is where we'll plug in y equals 8. But instead of just writing down y, isn't y also equal to 3x plus 1? Yeah. So I'm just going to plug in the 3x plus y in for y, or 3x plus 1 equals y. Now, if these two equations, if the graphs of these equations cross somewhere and they intersect, then the y and the x value will be true for both statements. Now, if I plug one equation into the other and I don't get a solution, I get like 3 equals 3, or negative x times, or I'm sorry, like negative 7 equals 0. If the statement's false, then there's no solution. If I get 3 equals 3 when I go and do all this math, it means all real numbers, infinitely many solutions. I shouldn't say all real numbers. I should say infinitely many solutions. Okay? So what I'm going to do is I'm going to substitute 3x plus 1 for y. Now I'm going to combine like terms. Well, what does that mean? Well, I've got 4x's plus 3x's. How many x's is that? 7 x's total. 2x terms, but it's 7 x's total. 7 x's plus 1. Now, if I want to get x by itself, I got to move the 1 away. Since I'm adding the 1 to the x, to move it away, I do the opposite, which is subtract by 1. So I'm going to subtract 1 from each side. What's 8 minus 1? 7. Now, how do I solve for x? Well, 7x times 7x means 7 times x. So to get that 7 away, I'm going to divide by 7 on both sides. X equals 1. Okay. All right. Now, what I'm going to do is I'm going to go back to the original equation, the first equation, and I'm going to substitute 1 in for x. So there was an x here, and wherever there was an x, I'm going to plug in 1. What's negative 3 times 1? Wow, that was loud. Negative 3 plus y equals 1, right? Now what do I do? I'm going to add 3 to both sides because I got to get y by itself. What's 3 plus 1? 4. Man, my tablet is acting bonkers. Anyways, so what that's telling me is that when x equals 1, what does y equal? 4. Now, how can I verify this? Yeah, I could graph it. Now, what you could do the graphing calculator, or if you're feeling fancy, we could just graph this in Desmos. I like to show you guys how to do both calculators. So you just go to Desmos, you go to graphing calculator, give that a second to load. Negative 3x plus y plus equals 1, I'm sorry. So I'm going to say negative 3x plus y equals 1. Did I get that right? Yep. And then 4x plus y, and the next one, 4x plus y equaled something, 8. Now we said that 1 comma 4 was the solution. Is this the solution? Yeah. So we're just going to take our handy dandy calculator, and I'm going to copy and paste that, and we'll put it in the notes somewhere. Okay, does anybody have any questions? Does that make sense to you guys? So let me zoom out for just a second. I'm going to talk about it, recap it, and give you guys a chance to write it down. I realize I got all this stuff and I go kind of fast. But we have 2 equations. The solution to the system of 2 equations is that we're looking for where the 2 equations share the same x and y. Well, that occurs when they intersect, right? They have the same x value and the same y value where they intersect. Well, one technique we could use is called the substitution method. Now, the substitution method is I take one of the equations and I solve for x or y. That's what I did here. I noticed that this equation, if I just moved the negative 3x to the other side of the equation, then I'd have y equals some stuff. So once I do that, I plug it back into the other equation, and wherever there's a y, I would put in the positive 3x plus 1. Then from there, if you notice, once I plugged that in, I had nothing but x's and numbers. We could solve x's and numbers. I can't solve this when I have an x and a y, because if I get x by itself, there's going to be a y somewhere, and I don't know what the value of y is. If I go to solve this one for x or y, that's why you have to substitute it in. Whenever you substitute something in, you eliminate one of the other variables. Does that make sense? All right. So now to double check that, I printed it in the graphing calculator, but let's go ahead and do it manually because I forgot that you guys got to do this in your textbook. So then we could check the solution by graphing. So one way that you could graph quickly is we call it the, you use the intercepts. Some call it the pinky method. Sometimes it's called the pinky method. It's a really quick way to graph equations. So, and I'll try to illustrate this. This is a really quick way to graph something. So you take this first equation, right? Now, what's interesting, if I say negative 3x plus y equals 1, okay? The pinky method is finding the x and y intercepts. So remember that the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. So make a table of values like this, and we're going to make a 0 for x and a 0 for y. Does that make sense? Now here's an interesting thing. I want you to think for a second, and we're gonna this is what I want you to see. Oh shoot, it doesn't cover it up. Dang it. We'll just do it this way. Oh, it won't let me do it. Well, heck. All right, so let's just do it anyways and see how this works. You're going to be able to see, but you're not. If I plug in 0 for x or y, so in this particular case, I plugged in 0 for y. Well, when I do that, this term goes away, right? In other words, they call it the pinky method because what you're supposed to do is take your pinky and cover up the y value, right? So you don't see that. Well, then what is the x value? Well, you would take this. In other words, this term, I'll just do it. Well, this goes to 0, right? So if I make this equal 0, you get this for an equation. What does x equal? Well, you would divide both sides by -3, right? And so this becomes -3, or -1 over, or 1 over -3. So when x equals 0, you've got -1 over 3. Now, if I do the same thing for x, then the x term goes away, and I have y equals 1. Or not the, I'm sorry, I put that in the wrong spot. This is -1/3, and this is 1. See how I caught that mistake? All right, so what does that mean? Well, if I just graph these two dots, I can draw a line between them, and that's how I graph my function. So I'm going to go to 0, right, comma 1, that's the y-intercept. And then I'm going to go -1/3, 0. So you have, this is what we call the y-intercept, and this is what we call the x-intercept, where it crosses the x and y axis. And if I draw a line through there, and in fact, if we go back and grab the graph, well, I don't have the whole thing, but if I zoom out a little bit, let me zoom in here. You can see that this right here is 1/3, and this is 1. See how that worked? So let's go back, and we know that's true. So I'm going to draw a straight line as best I can, which is going to be a little challenging for Mr. Adams with this tablet. So I'm just going to take, and I'm going to draw a semi-straight line between these 2 points as best Well, that's not quite straight enough. Okay. And then if I do the same thing for this other one, when I plug in 0 for y, this kind of goes away. And so then I just divide by 4 and divide by 4. So what's x equal? 2. If I reset that and I plug in 0 for x, this goes away and y equals 8. So I've got 2 points. I've got 0, comma 8. That's the y-intercept. And then I've got 2, comma 0. That's the x-intercept. So now I'm going to graph those. So I'm going to say x, or 0, comma 8. This is one of them. And then 2, comma 0. And then I draw a line as best I can through those 2 points. And they cross right at the intersection, which would be 1, comma 4. Okay? So then the solution is still 1, comma 4. Does that make sense to you guys? Is there a more efficient way to solve for x for the equation negative 3x plus y? What do you guys think? Yeah, what is it? You don't know? Use a calculator? I don't know. Well, yeah. Well, just think about it. How would you solve for x? What would you do to solve for x? What would you have to do? You'd have to subtract y, right? Move it over to the other side, then divide by negative 3. Is that efficient? Is it more efficient than what we did? So the short answer is not in this case. So just say no, not for that equation. Takes more steps. And so what I'm saying is if I say negative 3x plus y equals 1, to get x by itself, I got to subtract y from both sides. That's one step. That gives me negative 3x is equal to negative y plus 1. Then I got to divide by negative 3, then divide by negative 3, and then divide by negative 3. And I would get y is equal to 1/3. X is equal to 1/3 y minus 1/3. Then I got to plug that into the equation, and then I got to do a bunch of stuff to get that to work, where the other way, the way that we did it, was a little more efficient. Does that make sense? Okay. Now, sometimes that isn't the case, but we look for those things when we go to solve systems. That's what we look for. Is there another way to solve the system? Well, yeah. We could have taken take the other equation, 4x plus y equals 8, and solve that for y. Which would have been negative 4x plus 8, and then substitute it in. Is there another way to check your solution? Plug in x equals 1 and y should equal 4 for both equations. Does that make sense? Whew. That was a lot of work, wasn't it? All right, I'm going to zoom out and give you guys a chance to write all this down. That took us a little bit. Mr. Adams had to think about how to write it and how to explain it. Thumbs up, thumbs down on this. How do you guys feel? Okay, I'm going to be a little more specific. Thumbs up, thumbs down on graphing. How do you guys feel about graphing? Okay. Thumbs up, thumbs down on why we solve for x or y. Okay. Here's where I think the challenge is going to be. Thumbs up, thumbs down on plugging one equation into another. Yeah. That just takes practice, guys. That just takes practice. We'll keep working on it, though. All right. I'm going to leave that up so you guys can finish writing it down. Are there any questions? We're going to do another example if we have time. I don't know if we will.